Congratulations, you have your graph made. So now it is time to calculate the Hubble constant. In order to calculate the Hubble constant, we just need to determine the slope of our best fit line. So, so we're going to calculate the slope of the best fit line. So the Hubble constant can actually be expressed by the equation v, which is the apparent radial velocity of the galaxy, equals the Hubble constant times d, the distance to the galaxy. So we then, if we have either the velocity or the distance to the galaxy, then we can calculate the other one. So the Hubble constant then is used in that equation. So our units for the Hubble constant will be kilometers per second per megaparsec. All right, so let's go ahead and go to our graph. Now, I've actually printed out a copy of the graph, and I'm going to use my overhead camera and a printed copy of the graph in order to show you how to calculate the slope. So, now you've done this before in your math classes. The slope of the line, and the darker line is the one that I've added. Remember, it has to be at the origin. So we're going to use the darker line to calculate the slope. So just as a little refresher, I need to make sure you can see this. Slope equals two values on the y-axis. You're going to take the difference between them over two values on the x-axis in the x direction to calculate our slope. So I need to look for two dots, 2 points. Remember I asked you to create your graph with all these extra grid lines? It was to make this a lot easier. So I'm going to pick 2 points. Here's a point that's at an intersection. I'm just trying to make it easy for myself. And then I'm going to look for another one. This one's probably the closest. So I'll take that one. So my y-axis values are here and here. Well, that one's easy, 10,000. So 10,000. And I need my other value there. So my divisions aren't even. That's okay. You can use your calculator. I don't mind demonstrating. So we've got 3 divisions here, and that's 10,000. So 10,000 divided by 3 is 3,333, and there's 2 of them. So I'm going to times 2. And then I'm just going to add that to the 40,000. So it's 4, 6, 6, 6, 7, and I'll round up 1. Okay, that's my y values. Now I need my x values. Well, this one's easy, 250. There's that one, 100. 250 minus 100. Now yours, of course, will be different. All right, so 46,667 minus 10,000 is 36667 divided by 250 minus 100 is 150. All right, so I'll go ahead and work that out. And that is 244 is what I got for the constant. All right, so I'm going to put that into my data table. And that's going right there. 2 4, 4 is the number. And then the units that go with that are kilometers per second per megaparsec. All right, so that value is not the currently accepted value for the Hubble constant. That value is higher than the currently accepted Hubble constant. The currently accepted Hubble constant is about 70 kilometers per second per megaparsec. But I don't want you to worry that that number is off, because your number will be off too. Edwin Hubble's value for the Hubble constant was off also when he first calculated. He got around 500 kilometers per second per megaparsec. But our currently accepted value is 70 kilometers per second per megaparsec. All right, so I want you to use your graph and calculate your Hubble constant.